All right, so in the first video, we worked on actually finding summations and understanding the notation. This second part is all about actually writing each series in a summation notation. Now, what you should note about this is actually very similar for what we did in 13.1, where we had to write the this is very similar to where we had to write the general formula for a term. So the very first step is we're going to need to write an expression that will produce the numbers in the series. Which means we have to look for the same patterns that we looked for before. So I typed just a little bit out of those notes from 13.1, but really you should look back to 13.1 if you're struggling to find the pattern. Remember that we were looking for, does it go up by the same amount? If it does, then it's, then we have our general formula here. If it's not going up by the same amount, then we need to look at exponents and think, is it going to have the same base to a different power or a different base to the same power? And we also have to look at alternating signs. Oops, sorry about that. That shouldn't have made it that dark. So we're going to look for alternating signs. In other words, if it's positive then negative, and if it's positive then negative, then if our first term is negative, we start out one way. If our second term is positive, we start out the other way. And that's the stuff that we had looked at, like I said, in 13.1. So when I look at this one, I always try to look to see if they're going up by the same amount. So 9 plus, what would I have to add to 9 to get 16? 7, right? And then 9 would get me to 25, and then 11 would get me to 36. So these are not going up by the same amount. So not going up by same amount. So that means I need to look for a different pattern, right? If they're not going up by the same amount, then we need to look for something else. We need to look to see, are exponents involved? Could I do something to a power to get each of these numbers? Well, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and 7 squared is 49. So this is the idea of exponents, but it's not going to have the same base. They would have different bases because we use the base of 3, 4, 6, but it has the same power, right? So the idea is it's going to be some number squared would get me to that. Now the issue is when we think about this, we have to think about what number should we start on. Well, we want to start at 3, right? But normally we don't start out at 3. So I need to think, if n equals 1, would I have gotten this answer? Well, no, because I need to get to a 3. So n equals 1, what do we need to do to make it a 3? Well, we need to add 2 to it. Add 2 to base to get 3. Oops. We need to add 2 to the base to get 3 so that then we can square it. So the idea is, even though this is my starting point, right, I then need to say, well, I'm going to have to add 2 to that n before I square it. Because then 1 plus 2 is 3, and 3 squared is 9. 2 plus 2 is 4, and 4 squared is 16. 3 plus 2 is 5, and 5 squared is 25. So this, n plus 2 being squared, is the expression that we're going to use if n equals 1 is the first term. And normally we go off of that, the idea that we're going to use n equals 1 to start out with. Well, now this expression and the idea that it works when n equals 1 is going to give us our basis for our summation notation, right? So then we need to keep going with it, right? So far I would have summation, and then we'd have n plus 2 squared, because this is the expression that we're dealing with, right? And then step 2 is to identify the value used to get the first term. So in other words, what number am I going to plug in for n so that I end up getting the 3 squared? Well, we already said we would have to plug a 1 in. And normally, it's going to be 0 or 1. And this is what we write under the notation under the sigma. It is the variable equals the number. So since we said this was true for n equals 1 as my starting value, so that 1 plus 2 is 3 and 3 squared gets me my first term, then that's what goes underneath. After that, I need to figure out what goes on the top. So I need to figure out what goes on top of the sigma. So I need to identify the last value that will be substituted in. Well, and write that number above the sigma. So in this case, if I look at this, we used 1 as our first term, then 2 would be the second, 3, 4, 5. So 5 is where we're going to stop at. And then your last step should always be to check that the summation notation produces the series. Oops, sorry, you couldn't see that. So check that the summation notation produces the series. So since our series was 9, 16, 25, 36, 49, so if I plug in 1, 1 plus 2 is 3, and 3 squared is 9. Then I would try 2. 2 plus 2 is 4, and 4 squared is 16. Then for 3, 3 plus 2 is 5, squared is 25, so that works. For 4 plus 2 is 6, and 6 squared is 36. For 5, 5 plus 2 is 7, and 7 squared is 9. And since 5 was my ending one, that is correct. So this is our final summation notation. As you notice, like that beginning part is all from what we had done the past couple of days, and then this part is the only new part, stating where you're going to start and where you're going to stop. So let's do a couple of examples of those. So when I look at number 1, as I'm looking at this here, I notice from 3 to 4, we're adding 1. From 4 to 5, we're adding 1. From 5 to 6, we're adding 1. So we're adding 1 each time. So that tells me that since my numerator stays the same, that I can go ahead and start with just a 1 on the top. And then on the bottom, we're doing a 1n because we're multiplying whatever it is times 1 to get to the next piece. So now when I look at this, the issue is, let's pretend n equals 1. Is 1 times 1 going to get me to 3? No, it doesn't equal 3. 1 times 1 equals 1. So now what do I have to do to the 1 to get a 3 in the denominator for my first term? Because I need to get a 3 in the denominator for my first term. Well, 1 plus 2 would have given me 3. So if I add 2 to the bottom, that should help me out. So let's look and see if that would work for all of them. So right now I have 1 over n plus 2. So this number would be 1. This is my second term, my third term, my fourth term. So 1 plus 2 is 3, so I would get 1/3. 2 plus 2 is 4, so I would get 1/4. 3 plus 2 is 5, so I'd get 1/5. And 4 plus 2 is 6, so I would get 1/6. So I know that this is the beginning part of it. So we have our summation. 1 over n plus 2 is what we're taking the sum of. We started out at n equals 1, and we have 1, 2, 3, 4 terms. And I already know that works because we checked it as we went through, so that's our final answer. Now, number 2 is a little bit more difficult because when we look at this, the first thing I notice is that we are alternating from positive to negative, right? So we have an alternating series. Okay, so when it was alternating signs, we had to look what was our first term. Well, our first term here is negative. And since our first term is negative, what we said before is that -1 to the n power is going to be what we start with. Now, let's just ignore the signs and just look at the numbers themselves. So we have 1, 4, 7, 10, 13, 16. So I'm just looking at the base value. I don't care about the positive or negative right now. Well, if I'm going to go up each time, isn't this really adding 3 each time to get from each one? 1 plus 3 is 4, plus 3 is 7, plus 3 is 10. So after I take care of that alternating series, I notice that it goes up by 3 each time. So really, I have another base that I'm starting out with, which would be 3 times n. Well, if we're pretending that this is 1, right, my first term is n equals 1, well, 3 times 1 would give me 3. But I need a -1. So what do I have to do to the 3 to get to a -1? Well, I'm going to have to subtract something. What do I subtract to get to -1? Well, 3 minus 4. 3 minus 4 is what would end up giving me a -1. So if I have 3n, but I don't care about the negative. The negative is going to be taken care of by this piece. So it's not really 3n minus 4. I'm trying to get to just a plain one, so it should be 3n minus 2. So let's see if that works to get me to each one of these, because I'm already taking care of the positive and negative by this. Now I just care about producing this one. So 3 times 1 is 3, minus 2 is 1, so that works. Now we're trying to get to the positive 4. So 3 times 2 is 6, minus 2 is 4. 3 times 3 is 9, minus 2. So remember, when you're doing this part, again, ignore the negatives at this moment, because we already took care of the negatives by doing this piece. So now we have 2 base pieces. This will get me my negatives, and this will get me my base numbers of 1, 4, 7, 10. So we have -1 to the n times 3n minus 2, and that's the base of my summation. And this was my first term, which I chose to be n equals 1, right? And then there were 1, 2, 3, 4, 5, 6 terms, so 6 is my ending term. And then you should go back and check and see if it works for all of them, which it does. All right, then I'm going to have you try 3 and 4 on your own. So you have to try 3 and 4 on your own. And the last thing that we're going to look at is going to be writing out the terms of a series. And this is actually the simplest of them all. Okay, so we're going to go through those steps real quick, and you're going to try a couple on your own as well. Step 1 is to substitute values into the appropriate variable. The reason why I say appropriate variable is because, look, there's both an x and an I in this problem. So I'm not going to plug them in for both. This says I is 0, so I'm only going to plug this in for the I. So I would be doing 2 to the 0, x. Well, 2 to the 0, anything to the 0 power is 1, so this would be 1x, which is x. And we have to do that until we have to stop, which is at 4. So then 2 to the first power times x. Well, 2 to the first power is 2, so this is 2x. 2 to the second power times x. Well, 2 to the second power is 4x. 2 to the third power times x. 2 times 2 is 4 times 2 is 8, so this would be 8x. And then we stop at 4, so 2 to the fourth power x is 16x. Now that once we substitute it in, we actually did both of these steps. We substitute and we simplify each term. And once we simplify each term, then we can actually do what it's asking, which is to write out the series. So write as series. And remember, the series just means the terms added together. So we would do x plus 2x plus 4x plus 8x plus 16x. and leave it like that. No need to even combine like terms, because all we were doing was writing out the series, not actually finding the summation of it. All right, so let's do example 3 together, and then you'll do example 2 on your own. So this is from 0 to 3, but just for the k, right? So we have x, and then a subscript of 0 plus 3 would be x base 3. Next one we would try is 1 plus 3, which would give me x base 4. Then 2 plus 3 would give me x base 5. And now we stop at 3, right? So it'd be x 3 plus 3, which is x base 6. So then my summation is x base 3 plus x base 4 plus x base 5 plus x base 6. Okay, remember to try all the other problems on your own and come in with any questions tomorrow.